मार्क्स, बस थोड़े से मार्क्स से रह गई। बायोलॉजी ठीक था, केमिस्ट्री भी, पर फिजिक्स वो फिसल गया। इस बार पढ़ाई नहीं, तैयारी करो, वो भी स्मार्ट तरीके से, क्योंकि इन्फिनिटी लर्न लाए हैं अट्रेया, इंडियाज मोस्ट पावरफुल नीट रिपीटर्स प्रोग्राम विद P²CB, जिससे फिजिक्स पे होगा डबल फोकस। डोंट जस्ट मेक इट योर लास्ट ट्राई, मेक इट योर बेस्ट वन येट। जॉइन इन्फिनिटी लर्न टुडे।
Hi students, good afternoon. How are you all? Welcome to one more amazing session from Infinity Land. This is Suresh, Faculty of Chemistry. So, in the previous class we discussed about the history of periodic table, and today we are going to discuss about the continuation of the same history along with the pattern of the periodic classification. And you are going to really enjoy with the nice animations that are available right now in today's class. So, my dear students, please confirm you all able to can see me and hear me. And before going for this session, just a formal thing, it is a promotion of Atreya program. While you are preparing for NEET examination, the major hurdle everybody got is going to be your physics is this difficult subject. Hey Hanisha, good afternoon. You are not there in the previous class, beta. How are you? So, to avoid that problem, it is a universal problem for everybody. So, Infinity Lane by Sri Chaitanya Academy is bringing you the Atreya program. So, this Atreya program will make you, let's change your status I didn't do to I will do. Crack NEET examination. Sri Chaitanya Academy Infinity Lane is introducing Atreya program, India's most powerful NEET repeaters program. And it is P²CB where physics twice a day and chemistry and biology. Enroll now in the description box, the link is available. Gabisha, hi. Fine, very good. Let's see the details about Atreya. And this Atreya program revolutionizing NEET preparation with P²CB. Double focus on physics along with chemistry and biology, my dear students. It's really awesome. Infinity Land want to come out with certain limitations, and the limitation barrier is removed, and Atreya program is make you to physics comfortable, and your physics score is on us. Definitely we can go ahead with that. Let's go into the C and the program details. And batch commencement from 23rd of May, and still you have a batch is going to be commenced, you can join there. And days of the week, you can see the question classes from Monday to Saturday, Sunday ke chutti hai. And duration of the each class is going to be 90 minutes, and there will be 3 sessions per day, 2 concept classes, 1 practice class. And also there will be 18 classes per week, उसमें physics का double program भी है. And also an awesome thing I just want to show you, my dear children. You are going to see 465 classes, interactive classes by experts, and there will be 240 TPPs and dedicated practice class about 240 hours. And also after class you are going to get the class session automatically in the PDF format, and coverage of total 11th to 12th syllabus, and the most important part was going to be there will be batch size of 20 to 25 in a practice session, so that you will be having a very good rapport and also connect with the faculty, expert faculty. You will be having customized doubt clarification. So you won't be a 1 in 100 students, you will be in 1 in 20, 25 students, so that you will be having a better emphasis and a better scope of interacting with the faculty, and faculty will understand you and they can give you the appropriate suggestions and doubt clarification as far your requirement is concerned. And this program is so powerful, and you can improvise your chemistry, biology and physics into physics. So physics is a nightmare subject for these NEET preparing students. My dear children, NEET 2025 is given you the example, it's slapped like anything. And you won't be slapped again and again, because this program is scientifically designed in such a way that definitely you can do this best. ओके जो बच्चों अच्छा किया इन लोगों को एक नीट 2025 रैंक कॉलेज एंड प्रेडिक्टर फॉर एम्स जिपमर एएफएमसी एंड एनी गवर्नमेंट कॉलेजेस and find your dream medical college by clicking the link, and you can just enter your details and find your score predictor and rank predictor and college predictor BM. Okay, we are done and we are into the periodic properties and periodic table, and we are going to connect with the previous class and just a short recapture about what exactly happened in the previous class. My dear children, ready? A thumbs up and fire emoji before we start the class. Yes, Anisha, Gabisa, right. Now let's talk about the periodic classification. Why do we need to arrange the elements? Yes, we need to arrange the elements because the modern periodic table we have systematic nomenclature and also how the elements are seen and different animated form. I just want to show you. So the thing is here, look at this, and why do we need to classify the elements? There are 118 elements are there in the periodic table. So how do we know that? How do we organize in a block wise or a serial number wise? Yes, it is there. How do you find a book in your interest of the library? If the dump of books are there, and if in the kitchen trolley you can see various cutleries and all, how do you classify them? And these are all given as books. If it is jumbled, it is very difficult to identify. If it is classified, it can be identified. And how it is, see in the classified version of the cutlery also can be seen. My dear children, here you can see if the books are seen in English, chemistry, physics and biology, and you can take any book of your interest because it is classified under physics. You can take any book of your interest, chemistry, it is classified under chemistry. Are you getting or not? Clear, bacho? So for that we have so many atoms are made, and for that 1 to 118 elements so far it is known, and we require a systematic way of classification. To ease the problem of studying the elements separately, scientists searched for a system where the organization, knowledge and classify the elements, my dear children. And first one is Dobereiner triads is given, and if you see the periodic classification, what is the name? Here the periodic is shown here, because certain properties are repeating with certain intervals among themselves. For that we need a periodicity, and this periodicity is observed by classifying the elements in various methodologies, and we are going to see these various methodologies. Okay, developments on the periodic classification, you can see here, first law of triads is given, Dobereiner, then Newlands octaves is given, then Mendeleev periodic table is given, then Moseley periodic table, then modern periodic table, and chronological order, this is the one. In the chronological order, this is the one you can see. Meanwhile, telluric helix is there, we don't use it, we don't discuss it. We have Lothar-Meyer atomic volume curves are there, we don't discuss it here. Okay, if required we can discuss it, and the same we are going to see in the periodic properties. So let us start with the law of triads over here, and law of triads, Dobereiner law of triads. You see in 1829, near about 200 years ago, can you believe it? So John Dobereiner, he made it a group of 3 elements, and these 3 elements, you say, atomic weight of the middle element is the average of the first and third element, and he made a group of 3 elements with similar properties, that is called a triad. Sir, you please, you can ask a doubt, please. Football edit 06. Yeah, please you can ask a doubt. You, as far as this subject part is concerned, I am ready today. So let us discuss about this Dobereiner triad. Dobereiner triad is triad means a group of three elements. In this group of three elements, first element and the third element, arithmetic mean is going to be the atomic weight of the second element, middle element. And he made so the chemistry को chemistry क्यों बोलते so chemistry इसीलिए chemistry बोलते हैं. So chemistry is always a mystery and history is a chemistry. ठीक है? Mystery in the history is a chemistry, right beta? Very good, nice joke. Let us talk about, so this is a triad. Here it is a triad, here it is a triad, here it is a triad. मैं क्या बोलना चाहता हूँ यहाँ पर? So lithium, potassium, sodium, ये three elements related to the similar properties beta. And the atomic mass of lithium is 7. Atomic mass of potassium is 39. 7 plus 39 divided by 2 is going to be 23. ये किसका atomic mass है? सोडियम का atomic mass है. इसे आपको कैल्शियम एंड बेरियम 40 प्लस 30 137 अपॉन 2 इसका स्ट्रांसियम का बराबर होगा. सो क्लोरीन 35.5 एंड आयोडीन 127. ये एवरेज ऑफ क्लोरीन एंड ब्रोमीन का एटॉमिक मास ब्रोमीन का बराबर होगा. अनिशा, सोडियम, स्ट्रांसियम एंड ब्रोमीन. करेक्ट आंसर. सो आई हैव एन एनिमेशन हियर. You enjoy this animation. You can see, dear children, 7 plus 39 by 2 is equal to 23, that is sodium. 40 plus 137 by 2 is going to strontium, 88. 35.5 127 by 2 is going to be bromine, IT. You love it? You like it? Wonderful presentation. Wonderful presentation. So our team is working so nice to make this, right? You can see the numbers again. You can see the numbers again, how this average is taken. Dear children, you like it, Anisha? Great, great, great. Now moving ahead, right. So drawbacks of Dobereiner triads. Since Dobereiner relationship referred to as the law of triads seems to be work only for few elements, it is dismissed as it's a coincidence. There is no logical approach for that. No scientific reason is being explained. It is just a coincidence. And he made Newlands octave 1865. In 1865, Newland is given octave, just like a music chord. Now we can see, my dear students, arrange the elements in increasing order of their atomic weights. And noting that properties of every eighth element is similar to the first element. And just like a music chord here, John Alexander Newlands. Itna kiya na? So at least we need to know the name and the face, right? So let's see how he identified. So this is your music chord like this, sa re ga ma pa da ni. How many of you know music? Please mention in the chat box. So when you see just like a music chord, so elements are arranged in increasing order of atomic masses, and it is found that the eighth element is similar to the first element, just like a music chord. Eighth element similar to the first element like this. So this is what it is mentioned. It is happening is also like this. Okay, it is happening like this also. Yeah, right. The fusion. Now it is said sodium and lithium have similar properties. Potassium and sodium have similar properties. Calcium and magnesium similar properties, aluminum, boron got similar properties, bacho. And here only up to calcium dot. After calcium you can't do it. After calcium you can't do it. Understand? That is the actual drawback of this Newlands law of octave. Here helium is not shown, Neon is not shown. Are in 1865 noble gases are not been discovered. So first of all, he observed there is an increase and decrease in some similarity in the patterns. That is a noteworthy point in Newlands octave. That's why we still observe, and there is a property is repeating with say regular interval, that is what is called periodicity. They want to correlate, scientists want to correlate how the properties of the elements are being changed as a time, a regular interval. Yash, Array, if you don't forget to fill the code in the NEET OMR, it is difficult, and it has to be. Okay, and यश बनिरवाल, ये दुखी बात है बेटा, अगले एग्जामिनेशन में अगले साल में यह पहले ड्रॉप कर लो बेटा. ओके, सो यू कैन प्रिपेयर इट फॉर नीट 2026. यश, fine. And if you don't fill the detail, how do you get the expected result, right? Anyways, you do well. So talking about Newlands octaves, you can see in this Newlands octave drawbacks, my dear children. It is said that arrangement of the elements only up to calcium was possible out of these 56 elements known at that time. And after calcium, that is not correlated. Okay, that's why Newlands octave is lost. And Mendeleev, Dmitry Ivanovich Mendeleev, Russian scientist in 1869, he made the elements to classify according to the atomic mass, atomic weight, and arranged a periodic table. That is Mendeleev periodic table, Dmitry Ivanovich Mendeleev. And he did the first tabular form of the periodic table. According to the Mendeleev, the properties of the elements are the periodic function of their atomic weights. And let us see how this periodic table is designed. What is the special about the Mendeleev periodic table? Mendeleev periodic table, he ignored the order of atomic weights first of all. He placed the elements with similar properties together. And surprisingly he adjusted the atomic weights of elements assuming that they were not measured accurately, so that he corrected atomic weights of certain elements. And still he got the periodicity. And he predicted the properties of some undiscovered elements and left several gaps as well. And you have eka aluminum, eka silicon. Okay, their later is germanium and gallium, they are discovered. And if you see this periodic table here, we have 7 horizontal rows are called periods, and the 7th is not seen here, and 8 vertical columns are called groups. And one important thing is each group is subdivided into A and B category. A and B category, and A and B category they placed it. And of course, 8th group they have A, B, C category, and he cannot explain why so A, B, C category, and later on 0 group is being added by Moseley. So by the time noble gases are discovered, and still it has some problems. Drawbacks of Mendeleev periodic table. When you see the drawbacks of the Mendeleev periodic table, my dear children, hydrogen did not have a fixed position. And I want to say one thing here, hydrogen has no place at all even in modern periodic table, it is a debate. And there was no regular trend in increasing order of atomic mass while moving along the element. Some abnormalities are seen, anomalies are seen. And also isotopes, as he made his periodic table based on atomic weights, isotopes kaha gaya? Isotopes are the elements having the same atomic number but different atomic weights. अगर atomic weight अलग होने तो अलग जगह पे रखना है क्या? He has taken most abundant element and placed here. Thank you very much, Manan Khan. Thank you very much. And to avoid that, you can say Moseley, he modified Mendeleev periodic table in 1913. Moseley was a finest scientist. He shot dead by age 27 in World War II. Okay, he discovered atomic number. So, while conducting X-ray crystallography experiment, he conducted root nu is equal to A into Z minus B. So, nu is the X-ray characteristic frequency. So, it is a frequency of X-rays, and A and B are constants, and Z is the atomic number. And when you see this, he calculated atomic number of the various elements by conducting this X-ray crystallography, by calculating experimental value of the frequencies. And he found that atomic number is the fundamental property of the element, not the atomic mass. So, immediately he made his own periodic table by taking the replica of the Mendeleev periodic table. He has taken the Mendeleev periodic table and he removed all the elements on the blank periodic table. He rearranged the elements in increasing order of atomic numbers. That is Moseley periodic table. Moseley felt it, why A and B together? So, let us separate A and B category somewhere, right? So, A category and B category are separated. So, he got little lengthy version of the periodic table, that is called long form of periodic table. Manan Khan, hope you are understanding. So, this long form of periodic table, later it is connected with the electronic configuration and it is given as the modern periodic table, that is given by IUPAC and it is refined by Bohr. So, he is Henry Moseley. He is Henry Moseley. So, let us talk about the modern periodic table and modern periodic law. The physical and chemical properties of the elements or the periodic functions of their atomic number and electronic configuration. Anisha, say if you have any doubts, please let me know better. If you have any doubts, right. So, this periodic law is essentially the consequence of the periodic variation in the electronic configuration which determine the physical and chemical properties of the elements. Yeah. So, let us discuss about how this periodic table is designed. Modern periodic table, how these elements are arranged in the modern periodic table according to the Z. Yes, it is. In the long form of periodic table, you have horizontal rows are called periods. There are 7 periods and 18 vertical columns, they are called groups. Okay. And each period corresponds to the highest principal quantum number n of the elements in the period, and elements having similar outer electronic configuration seems to have their similar properties and automatically they are arranged in a group. Right, beta? And let us see the electronic configuration basis. Okay. Hello sir, can you please give me the insight how to balance equation? I am writing physics in a few hours, but I am struggling with balanced equations. So, right now, and your question is appreciated, my dear children. Here, this right now, we are talking about the periodic classification. In the next week, we are going to conduct a special session based on the redox equations and balancing the redox equations. So, I think you can join in that session as well. Right now, let me proceed with this current context. Take care. Present sir, Ram sir, thank you, Radhe Radhe. Okay, let's talk about the long form of periodic table, my dear children here. So, the modern periodic table, this is the modern periodic table. And let us see the scenario of the modern periodic table here. You can see this 18 vertical columns are called groups and 7 horizontal rows are called periods. You got it? And let us see any group you take, all the elements will have the same electronic configuration, right? Hey, na? And let us see all the things over here. Now, my dear students, modern periodic table ka maamla, nice animation is given here. Let's see in terms of the groups, 18 groups are there, their vertical columns are called groups and horizontal rows are called periods. These are called periods and these are called groups. Understand? And you can see this is the first group, second group and group 13 to 12, 13, 14, 15, 16, 17 and 18. You see the first group NS1 configuration. You have seen the NS1 configuration, NS2 configuration. So, NS2 NP1, NS2 NP2, P3, P4, P5 and P6. Are you getting or not? These are all called D block elements, where you are going to see the D block elements. It is N-1 D 1 to 10, NS0 to 2. And these are all called F block elements. We are going to see various types of elements in this category only. Understand? And you can classify them into the metals, non-metals, metalloids and everything. Hope you are understanding this. You like this animation? Yes. Hi, hi, hi. Hi, beta. So, let us see some more details about this. You observe how to study the periodic table. Do we have to memorize the entire periodic table? Eventually, you will learn it. As of now, no. Fine. Good afternoon, beta. Good afternoon. कुछ पूछना चाहता हो बेटा? अगर कुछ डाउट है ना तो पूछना बेटा. So enjoy this animation, बच्चों. And no, see how the electronic configurations are being seen. Thank you very much. Thank you. And let us see here. Period 1, 2, 3, 4, 5, 6, 7. Period 1, 2, 3, 4, 5, 6. These elements are placed here. Sixth period, these elements, lanthanides and actinides comes in this brick. Sixth period and seventh period. You can see there. The highlighting part gives you a lot of insight. Hai na beta? And this is going to be super awesome slides. अगर कुछ डाउट है ना तो जल्दी बोलना. Enjoy the slide. Yes, you like it? Right. Now, my dear students, here I just want to see the various blocks I will discuss. We can classify the elements into 4 blocks: S block, P block, D block and F block. The elements are classified according to the blocks, according to the differentiating electron enters into an orbital. And here you can see the differentiating electron is the criteria. So, what is differentiating electron? The electron by which an element differs from its previous element is called a differentiating electron. If the differentiating electron enters into the s orbital, they are called s block elements. My dear students, these are all s block elements. And the differentiating electron enter into the p orbital are called p block elements, and these are called p block elements. The differentiating electron enter into the d orbital are called d block elements, and the differentiating electron enter into the f orbital are called f block elements. Okay, s, p, d, f blocks. And let's see here the s block. These are called s block elements. They include group 1 and group 2. They have NS1 configuration, NS2 configuration, and they are called alkali metals. These are called S block elements. Right, beta? And you can see the S block, which includes hydrogen, for namesake it is kept, it has no place. Lithium, sodium, potassium, rubidium, cesium comes under S block. They have NS1 configuration, they are said to be alkali metals. They are said to be alkali metal. You want to see the information, village, Ganoli, Ruthavlini, please. I could not understand, sorry. So, I could not understand. Okay, right, beta. Let's talk about S block elements include alkali metal and as well as an alkali earth metal. And you can see here alkali earth metal. They include beryllium, magnesium, calcium, strontium, barium and radium. These are all called alkali earth metals. Of course, beryllium is exception where it is not considered as alkali earth metal. Why? Because this oxide of beryllium is amphoteric. And of course, they are called as in generalized, it is included, okay, alkali earth metals, they have NS2 configuration. NS2 configuration. And you have p block elements, the differentiating electron enters the p orbital are called p block elements, which includes group 13, they are called boron family. They are also called icosahedrons, they are also called as a boron family. Which includes boron, aluminum, gallium, indium, thallium, and they have the general configuration of NS2, NP1. You can say group 14 elements, they are called carbon family. Group of 14 elements, they are called carbon family. Carbon, silicon, germanium, tin, lead. They are also called crystallogens and carbon family. They have NS2 and P2 configuration. And also we have the p block elements, nitrogen, 15 group elements, nitrogen, phosphorus, arsenic, antimony and bismuth. They are also called as nitrogens or nitrogen family. They have NS2, NP3 half-filled configuration. So, because of the half-filled configuration, according to Hund's rule, it is going to have this configuration like this. Because of this half-filled configuration, they have the high ionization energy and high stability kind of things. Talking about oxygen family, group 16. Group 16 has an oxygen family, and oxygen, sulfur, selenium, tellurium and polonium. They are called as chalcogens. They are also called as oxygen family. They have NS2, NP4 configuration. This is the element called polonium, and this polonium is discovered by Madame Curie, and this Madame Curie belongs to nation Poland. On the honor of nation Poland, the polonium element name is given. Let's talk about group 17. They are called halogens and they include fluorine, chlorine, bromine, iodine, astatine. These halogens has NS2, NP5 configuration. Dear students, hope you are understanding. If you have any doubt, you please let me know. And the most reactive non-metal is fluorine, right? Halogen family, yes, exactly. So, you see noble gases, group 18 are called noble gases. They include helium, neon, argon, krypton, xenon and radon, and they are called as noble gases or inert gases. They have NS2, NP6 configuration. They have octet configuration. And helium is having 2s2 configuration. This is called duplet configuration. Bacho, Anisha, and the fusion, you tell me octet configuration, duplet configuration, उसमें ज़्यादा stable कौन सा होगा? among octet configuration, among duplet configuration, who is going to be the more stable? Who is going to be the more stable? You tell me quickly, and I am going to show you other way of classification. Expecting answer jaldi jaldi. Among octet and duplet, who is more stable? कुछ बोलना है क्या ना? अरे, among octet and duplet, duplet is relatively more stable as compared to octet. Both are stable, right? And they are completely filled orbitals. So, making to the d block elements. You know, except noble gases, all p block elements and s block elements are said to be representative elements or main group elements. Duplet is more stable, not octet beta. Duplet is more stable. ठीक है? Right. Now talking about the d block elements, these elements are called d block elements, the elements in which the differentiating electron enters into the penultimate shell of the d orbitals are called d block elements. Yes, the duplet is more stable. Why? Because the electrons are close to the nucleus, so that the nucleus is going to firmly bind the electrons as compared to octet. Exactly. What you said is exactly correct. So, this is a live interactive session, my dear students. I really enjoy to clarify the doubts from the students. Don't feel this as like a radio session. Okay. So, this is a live interactive session. I am going to honor everybody's message given in the chat box. Right? And I always encourage you guys, you can ask a doubt related to the context, so that we will be discussing this. So, with an expert faculty, you want to have this kind of live interactive sessions. You need to pay a huge amount of money, but nothing we expect from you, and you just freely join, and it's absolutely free of cost, and you can enjoy the classes. Okay. And if please like our session, share with your friends, and subscribe to Infinity Learn NEET YouTube channel. Anisha, I want you to be, you are a very good student, and I want you to be very regular in the classes. Okay? So, maybe due to some reasons you may miss it, but you can revisit the class recording, and you can still ask in the doubts in the comment box. I can just make you to understand. Okay? So, your name is just given the fusion. Okay, I will be comfortable if I know your name, right? Okay, anyways, so these are the d block elements. They are also called as the transition elements. So, Abhinav Yadav, Srimati, okay, anyways, and this is the d block elements, where they are also called as the transition elements, and these are all d block elements, bachcho. These are all d block elements. Carefully you see, and most importantly, and these are all called transition elements. These are all called transition elements. The elements in which the incompletely filled d orbitals are there, they are called as transition elements, and these transition elements has d orbital even at the ground state or any stable oxidation state or stable ionic state. So, let us see the d block elements. You have various d block elements. Because of this d orbitals, they have the unique properties. Okay, zinc, cadmium and mercury is copernicium is not regarded as the transition elements, however they belong to the d orbitals. And you can say the specific property of these all metals, these are all metals. Okay, and you have they may form colored ions because of the vacant d orbitals. Their general electronic configuration is n-1 d 1 to 10 and ns 0 to 2. You have, they can show variable oxidation state, like iron you take, it can show +2 oxidation state, it can show +3 oxidation state as well. And you can see here, they are going to see, they are also called as the transition elements, and majority of the compounds can act as, behave as a catalyst, compounds and the metals. And also say they can be a paramagnetic also. These are the specific properties related to these elements over here. And talking about F block elements, why are D block elements are called transition elements? You have any idea about that, Srimati? And why are D block elements are called transition elements? Yes, D block elements form a bridge between the chemically active metals and S block and less active metals like group 13, and they are in the transition, and they are hence called transition elements. And you see the F block exceptions in the D block. Zinc, cadmium, mercury have the electronic configuration n-1 d 10 to ns2. RCB, fan. Okay, we are not talking about anything about RCB or IPL matches. Okay, don't go crazy. And here NEET Nirman program chal raha hai beta. Okay, Shrikant, find they are going to have n-1 d 1 to 10 and ns2. They are not transition elements. So as they have completely filled d orbitals, so they are not regarded as transition elements. Okay, and you can see F block elements. These F block elements, cerium to lutetium and thorium to lawrencium, they are supposed to be present here, and because of there is no place, the elements are reported here, and because of the place accommodation issues, the 4f orbitals are being filled here. So they are said to be 4f series, and 5f orbitals are being filled here, they are said to be 5f series. When you talk about this transition series, now this transition series, you have 3d orbitals are being filled 3d series, 4d orbitals are being filled 4d series, 5d orbitals are being filled 5d series, and 6d orbitals are being filled 6d series. So that is going to be scandium 3d series, scandium to zinc, and yttrium to cadmium 4d series, and 5d series lanthanum to mercury, and actinium to copernicium. It goes like this. Somewhere but the lanthanum element don't belong to the group. Why it is so? Yes, exactly. Lanthanum belong to the d orbitals. That's the reason why in the F block elements you can see here lanthanum is the element belong to here. So we start F block element from cerium to lutetium. Lanthanum is belong to here only. You understand? I know this, please ask me one quiz. Definitely. Shrikant, definitely we can do this. Now let's see here F block elements. These are all the F block elements. Let's see the chemistry of the F block elements little bit, and you can see F block elements includes, they are also said to be inner transition element, and they have lanthanum to lutetium called lanthanides, and you can say it starts from cerium in the inner transition elements, and they have the configuration n-2f 1 to 14, ns-1 0 to 1, and ns2. Right? Here you can see n is equal to 6. In this case n is equal to 6. And while you can see the actinide series 5f orbitals are being built, and actinium Z is equal to 89 and 103, from thorium to lawrencium is going to be actinide series, and here the same electron configuration n is equal to 7. You know one thing, after uranium, these elements are all man-made elements. They don't found in the nature. They don't found in the nature, right? Okay, please concentrate in the class. Dear children, please concentrate in the class. Now you can see various elements I just want to show you here. क्विज भी है. This is your periodic table. This is your periodic table और एक animation भी है. Okay, you can see alkali metals. In the periodic table, these are all alkali metals, my dear children. Okay, and lithium, sodium, potassium, rubidium, cesium and francium. And let us talk about alkali earth metals. And these are all alkali earth metal: beryllium, magnesium, calcium, strontium, barium and radium. Hope you are enjoying this. Hope you are enjoying this. And you can see these are the transition elements. Actually the transition elements, zinc, cadmium, mercury, and they are not actually seriously taken, but in general it can be placed here, transition elements. And you can see rare earth elements. So rare earth elements and lanthanoid elements, scandium, yttrium and lanthanum, from here cerium to lutetium are called rare earth elements. And also you have actinoid elements. These are all actinium, so they are transuranic series. Okay, the scandium is not, yttrium is not there. Rare earth means lanthanum to lutetium. Okay, actinoid elements, actinium to lawrencium. Get it? Scandium and yttrium, it is a mistake over there. Okay, and you can see the other elements like aluminum, gallium, indium, thallium and tin, lead comes under this category. They are separately studied when their behavior is concerned. Fine. And also you can see metalloids. These are the metalloids. Okay, come on. No, be serious in the class. Be serious in the class. Okay, nowadays students, metalloids: boron, silicon, germanium, arsenic, antimony, bismuth, tellurium and polonium, they comes under metalloids. Okay, this please don't chart in a different way. Please students, please maintain the chart diagram. Okay, so what are the halogens over here? Here halogens are going to be fluorine, chlorine, bromine, iodine. Halogens are going to be fluorine, chlorine, bromine, iodine. Okay, and even in the noble gases, helium, neon, argon, krypton, xenon and radon. Okay, and other non-metals are also there. You can see carbon, hydrogen, carbon, nitrogen, oxygen, phosphorus and selenium, purely said to be is a non-metal. Are you getting or not? Clear? So this is the periodic table. We just enjoyed it in a different way of classification, you can see. So all these things are well done by our content team. Thank you very much, my PPT team over here. And let us go ahead with what exactly wanted to say. The elements, yeah. Now this is your periodic table again. In this periodic table, the similar classification is seen in one stretch. Okay, let us see how these elements are being named. That is the major thing. So you are going to find out very interesting things over there. Okay, how the elements are named in the periodic table, 118 elements. So there are some questions I just want to erase here. So maybe on the name of the scientist, maybe on the basis of the names, planets and Greek mythology, maybe on the plane of place of discovery. So the elements are being named based on that. Okay, so let's discuss about this. Maybe on the name of scientist, maybe on the meaning of the elements with its behavior. So 4 kinds of classifications are seen. The naming, because hundreds of years ago we know the elements, how it is named. Let's see how the elements are named. What is the common name of the element? Americium, germanium, europium and francium. These are the elements are named after their place of discovery, country names, place. Right? So interesting. It is interesting, isn't it? And you can see the francium, europium, germanium appear like this. And you can see some elements got their names from the name of the planets or stars too. Really interesting. Look like the elements of Mercury, Neptunium, uranium and plutonium and helium. And you see the Mercury and Neptunium. So don't say that uranium is obtained from Uranus. So don't feel like that. Okay, hope you are enjoying this. Now sometimes you can see the elements are also named based on their behavior, and you can see hydrogen got its name because of its from water. Rubidium is named so due to its deep red in color, and due to their faint glow in the air. Phosphorus got its name, phosphorescence. And also this is a red phosphorus. Can you believe it is a red phosphorus? Okay, it's the image of the red phosphorus. And nomenclature of higher elements with atomic number. So I just want, do you know about controversies regarding the name of the element with atomic number 104? Almost black, huh? Okay, black is completely black. It is just like looks like a graphite. Okay, and Americans named the Rutherfordium, whereas the Soviet named it as an Korchatovium, the same element. There is a controversy while naming. So IUPAC, International Union of Pure and Applied Chemistry, resolved this problem by systematic nomenclature of new elements. So that is for Z, atomic number is greater than 100. So simply you can say this is if 0 is there, you can say nil, 1 is there, un, 2, bi, 3, tri, 4, quad, 5, pent, 6, hex, 7, sept, 8, oct, 9, n. And you have to use suffix IUM, that's it. You want to write 104? 1 stands for un, 0 stands for nil, and 4 stands for quad, and suffix is going to be IUM. So the symbol of the element is going to be U, N, cube. Bas. Are you getting or not? Sometimes this will be given, you have to decode the number. That will be given a question from the NEET examination, my dear children. If you have any doubts, so please let me know. Fine. Dear children, yes, do it. Thank you. Very good gathering over here, my dear children. How do you write the element which is not actually discovered? 122. I want to see the chart box. I want to see the chart box. right? N by IUM UBB. Clear? Fantastic. So let's see what will be the IUPAC name of the element, atomic number 135. I want you to see in the chat box. Quick, quick, quick. And try pent IUM. UTP. Is that okay? Now you're learning. Great, great. What with the IUPAC name 122? We did it. Okay. So, what is a group? It is a column of the elements in the periodic table of the chemical elements, right? Then what is a block? It is a set of adjacent groups in the periodic table. And what is a period? It is a row in the periodic table. So, my question is, if an element is given, how do we write the group and a period? It is going to be here. Finding position of an element in the periodic table. It is a universal question. Okay, those preparing for NEET examination, bachcho, this question is all yours. You guys has a lot of confusion in that. I have a resolution with me. Now we can say finding a block, finding a group, finding a period, right? So finding a block, finding a group, finding a period, I have a simple trick over here I just want to mention here. Bacho, to find a block, first write the electronic configuration of the element and the orbital in which the last electron enters in the block is the block of the element. Okay. So, if you see example, if you write the electronic configuration, it comes to be 1s2 this is the last. So, the p orbital is being filled here. So, this element belongs to p block. Are you getting or not? Fine, beta. Finding a group. When you write the electronic configuration, in S block element, the group number is the number of electrons in the outer s orbital. In the p block, the group number will be the number of electrons in the outermost shell. You have to add 10. In d block elements, the number will be the number of electrons in the outermost shell plus penultimate number of electrons. Are you getting or not? Clear? And for period, you are going to say after writing the electronic configuration, the highest value of principal count number denotes the period. Chemical bonding probably in the Anushka Roy, chemical bonding will probably in the next week. Ready for that? Are you ready for that? And basics of organic chemistry when in the month after this month. Okay, if I start now chemical bonding, it completes this month. Okay, immediately I will start organic chemistry. Ready for that? General organic chemistry. Ready? But one thing, you please like the session. Sub like button mara Anushka Rai. So those who clicking the likes, that also comes to me. Okay. Anyways, please like the session and share with your friends and subscribe to Infinity Learn NEET YouTube channel. Subscribe kiya, jada subscriptions. So the volume only makes us. Yes, thank you. Thank you, Srimati and Fusion, Anushka Rai, Anisha. Max Gaming. So, game students, right? You are from Pakistan, welcome. Okay. So, welcome my dear. So finding the period. So these are the three major things I just want to give you for understanding a question from the various competitive examination, especially for NEET over here. Let's find the block. So I said find the block, write the electronic configuration of the element, the subshell in which the last electron enters is the block of the elements. Now it is elaborated. Right, beta? Fantastic, fantastic. And finding the group, write the electronic configuration. You are going to see the electronic configuration pattern can change you for the group. If it is S block, the number of S electrons, P block, number of P electrons plus 10, D blocks, total number of outer shell and penultimate shell. That's it. That is your group number, beta. And finally, finding the group and finding the block, I said. And in the periodic table, you can see the various elements are seen like this, and you can visualize this. Finding a period, after writing the electronic configuration, the highest value of principal quantum number, it denotes the period, right? So, thank you very much. Think, buddy. Anyways, so this is your, what is the period and group and block of a cesium 55? First, let us write the electronic configuration, and the cesium 55, it is going to be 6s1. When it is a 6s1, it comes to be 6 xenon, 6s1. Everybody, you can see in the periodic tables S1 configuration 1, 2, 3, 4, 5, 6. So this is your cesium. Got it? Clear? Fantastic. And let us do one thing. What is the period and group and block for bromine? So when you write this bromine, it is going to be 5s2, 5p1, and its electronic configuration is fluorine, chlorine, bromine and iodine, 4s2, 4p5, and it is going to be bromine first period, second period, third period, fourth period, and it is 4s2, 4p5 bromine. It is going to P block, group 17. Are you getting or not? Are you getting or not? Okay, this is how we can identify what is the period and group number for scandium 21. It is a D block element, and it is going to be argon 3d1 4s2. When it is said that argon 3d1 4s2, you are going to have this group 3 and period 3. Okay, exactly. Now let's see the overall periodic table over here again, and we'll come back with, yeah. Yes, this is the periodic table, various elements already we have seen. So, alkali metals, lithium, sodium, potassium, rubidium, cesium, francium, alkali earth metals, beryllium, magnesium, calcium, strontium, barium, and here transition elements. Here it is going to be scandium, yttrium, निकाल दिए, lanthanum to lutetium are the rare earth elements, and actinoid elements and other metals and metalloids, halogens, noble gases and other non-metals. Hope you enjoyed today's class. My dear children, hope you enjoyed today's class. And please like and share this session with your friends, and subscribe to NEET Infinity channel. And this is, we are done from our side. Thank you very much, and we'll meet with more stuff in the next class. We will start with the periodic properties like this. Ready for that? Thank you very much. Thank you. Say bye. Think, buddy. Okay. Fusion, Anushka Roy. Okay, bye. We are done from our side. Signing off, Suresh, Faculty of Chemistry from Infinity Land. Thank you.